Hello and welcome. In this iOS 6 discussion, we're going to begin talking about Objective-C specifically in the context of object-oriented programming. And we're going to start with a simple discussion of types and classes. Classes really are types, as we've already said in Objective-C. They're just like C types. They're pointers, but they are just like C types. So here we go. First of all, we'll talk about the C data types that we inherit from C. Objective-C is what we call a strict superset of C, and this means that anything we can say or do in the C programming language, we can do in Objective-C. Objective-C just adds object-oriented structures on top of C. Theoretically, C is almost there. We can set up a C struct, and it would have properties, right? We can set up attributes of that structure, but it doesn't have any methods. But we can get around that by placing function pointers inside the struct and sort of operating with this struct as kind of an object, but it's really not object-oriented. It's a structure with function pointers in it. Objective-C adds some object-oriented language on top of C. But the point is here that all of C's primitive and composite types are available to us within Objective-C. So we have char and short and int and long and even long, which is strange because it's the same size, byte size, of a long, but it's there for compatibility reasons. All of these integral types, these scalars, are present. We have floats and doubles and long doubles, which is a 16-byte length value. And these are our floating point types. And we also have the composite structures, arrays, structs, unions, and enums from C. Objective-C adds a bool type, and it's all capital letters, B-O-O-L. And this is for booleans, and this is a 1-byte value. True and false are defined because Objective-C inherits everything from C. But in Objective-C, we use yes, capital yes, and capital no for true and false, respectively. Objective-C adds a new type to C, and this is the class type. So classes are declared in their interface file or interface section of a file, and this is usually a header file, a .h, just like a C header file. And we declare properties and methods here, and we'll talk about what these are and how to do that. And then in the implementation file, which is a .m file, not a .c, as you might expect, we define the bodies of the methods for our classes. Nearly all Objective-C classes inherit from a single superclass, eventually, and this superclass is called NSObject. There's a couple of classes that don't. There's a couple of class graphs in Objective-C that don't, or in iOS, I should say, that don't inherit from NSObject. But overwhelmingly, for the most part, everything, you can think of it this way, everything in Objective-C in iOS inherits from NSObject eventually. And all of our model objects, certainly, are going to inherit either from NSObject or one of its subclasses. So let's talk about this interface file or interface section. The interface file is a C header file. It's a .h file. And the declarations of properties and methods that we talked about are contained between a pair of @interface and @end. Whenever we see an @ in Objective-C, an @ sign preceding something, it means that this is object-oriented. This is an object-oriented thing. And I won't go any farther than that. But it's kind of a signal to us. It's kind of like a hash mark for the C preprocessor, which also runs here. But the @ flags a Objective-C preprocessor, if you will, that adds in this object-oriented code. So we have @interface and @end. And everything in between there is either a property or a method declaration. We can also declare instant variables right after the interface line in a pair of curly braces. And ivars, by default, are private to the class, meaning that only an object of that class can get to those ibars. And that's a good thing, as we'll talk about later in the course. So how do we declare a property? Well, they're declared using the @property directive. And in a pair of parentheses, we can place in any order a keyword defining the atomicity, the setter semantics, and maybe a read-only keyword here. And then after the parents, we put the type and the name. So that atomicity keyword is going to be atomic by default, and this is used to avoid locking in multi-threaded settings. In most cases, we use non-atomic. There is no keyword atomic, so if you leave this out, it's going to be atomic. In most cases, though, we use a keyword non-atomic, all one word, to specify that we're not worried about threading in our setter. The second one, the setter semantics, controls the code that will be generated for the setter when we synthesize the property, and we're going to talk about that in the next slide. And if a property is marked read-only, then no setter will be generated. It will only generate a default getter. So we're going to talk about that a little bit more. Now, what these setter semantics keywords are, we'll talk about as we proceed with the course. I'm not going to talk about them today. Just know that they are there. Now, synthesis, on the other hand, is what we do with the property in the implementation file. So in the implementation file, we synthesize our properties, or in some cases, they are synthesized for us. But if we go ahead and synthesize them, it's not an error. So we should always just synthesize our property names. What this does for us is it creates both a default getter and a default setter. And the setter will use those setter semantics and the atomicity of the that are in the property declaration. Now, if we specify read-only in the property declaration, it will only create a default getter. So that's another wrinkle to that. The getter or the setter or both can be overridden. We can override them. And in that case, it'll use our version. It'll use the new version rather than the default version. And this is a good thing because many times we will end up overriding the getter that Objective-C gives us in order to do some different things. For example, we might want to just calculate a value in the getter. We might want to instantiate the class that the property is referring to in the getter. So we do a lot of things with overriding the getter. Now, methods. We've talked about properties and synthesizing them. Now we're going to talk about methods. In Objective-C, we interleave the parameters with the method names. So let's look at two pieces of code here. The first is a C function declaration, a typical C function declaration for a function named add that returns an integer that has two parameters, both integers, A and B. So you're familiar with this. This looks like C. It looks like Java. But look at the equivalent Objective-C method declaration. I've given colors to the parts of it. We return an integer, and by the way, that hyphen or dash is required, and we'll talk about that in the next slide. We return an integer, and it looks as if we're casting the function to an int, and that's really exactly what we're doing. But we're returning an integer, and the function name is still add. Notice the colon, and then we cast a to an int. So the first parameter is a, and it's of integer type. And then the next piece, this 2, is part of the name of the function. And again, notice the colon. And then we cast b to an int. So int a and int b are still present. They're just cast. And add2 is the name of the function, or add colon 2 colon, as it's sometimes pronounced. I forgot to put a semicolon at the end of this. I should have done that. So a little bit of terminology here. In Objective-C, we call a method of an object by, quote, sending a message to a receiver. The object is the receiver. The message is the method. So we put these message sends inside square brackets. We imagine that we have an object named myObject of some class that is capable of performing the add message. So add 9 to 4. And this is how we would call this message or call this method, by sending a message to the receiver. Methods, we can define a method to act on the instance of a class or the object or upon the class itself. Instance methods operate on any object, any instance of the class, and they can use the properties of that class because properties belong to the object. They are really another form of instance variable, which means that the instance owns them. So properties belong to the object of the class. An instance method is preceded by a dash, and the dash precedes the return type, as we just saw in the last slide. Class methods operate on the class itself, and because the properties don't belong to the class but to objects of a class, we can't use them in class methods. And we indicate a class method by replacing the hyphen or the minus or dash before the return type with a plus. And that's how we indicate a class method. So how do we instantiate a class? Well, we send a couple of messages. The first message we send is the alloc message. And we send this to the class name, to the name of the class. So, and this message allocates memory. And then with the result, we send the init message. So here's an example. Remember our class car. Our object is myCar. myCar is a pointer. It's pointing to a block of memory. So now notice how we have embedded the alloc message inside the init message. And this is typical. This is normal. We can embed messages within one another to an arbitrary depth. 2 or 3 is about the limit as far as good coding practice goes. But you can see here that we've sent the alloc message to car, and this will give us a block of memory on the heap. And then what we have here is an uninitialized myCar. In other words, we have an object at this point. It's a pointer to an uninitialized hunk of memory out there on the heap. Now we send the init to that instance, myCar, and now we're all set. The object is set to use. myCar is a pointer. All objects are allocated on the heap, so all objects are allocated dynamically. Alloc is a class method of car. Init, in this case, is an instance method of myCar. Now, init and alloc are declared, both they are declared in car, but myCar can use the init method, but can't use the alloc method, because alloc is a class method. Both alloc and init are inherited, however, from NSObject. And NSObjects gives us the base kind of concept. It is the ultimate root template for every object that we will create in Objective-C. Thank you very much.